Good morning, afternoon, or evening, Bearcats. I hope you had a good weekend, and we are now moving on to 1.6 parent functions. The first thing we're going to talk about are constant linear functions. There's a couple of special linear functions we need to talk about, and of course both are lines, but there's some special attributes of each. The first is a constant linear function, and a constant linear function is a horizontal line. Make sure you're taking your notes in 3 columns. And it has a range consisting of a single real number c. So the range value or the y value is that constant. What I'd like for you to do is I'd like for you to draw an example of that line and label it. I'm going to give you just a minute to do that, and then I'm going to draw one and we're going to check and see if we agree. Okay, so let's see. If we draw our axis, and it's a horizontal line, we'll make it down here. We're going to say that's at -3. The y value is -3, and we would write that constant linear function as f of x equals -3. And that's a constant linear function. The next thing is the identity linear function. Identity linear function, I think you might want to think of that as sort of the parent graph of a line. It is a line that has a slope of 1. And it has a y-intercept of 0, which puts the point at 0, 0, which would also be an x-intercept. Again, that's just your parent function, so let's take a look at what that would look like. You have a slope of 1, so you've got a y-intercept at 0, 0. We're going to have 1 here, 1 here, -1 here, -1 here. Got our graph labeled, so we'd have a point at 1, 1. At a point at -1, -1, and of course our line would go right through the origin. And again, this is something you would think of as the parent function of a linear function, but it's called an identity linear function. We would write that as f of x actually equals x. Slope of 1, no y-intercept, or 0, 0 for our y-intercept. All right, let's move on. Okay, I would take time now, and I don't have these in 3 columns because I pasted this from your book. It's actually on page 70, but I believe I would write this in one of your columns, and then I think I would describe the name. You could name it in the first column, so the column 1 would have, let's say, constant function. The second column would have a description maybe of your domain and range. I think that would be a really good thing. So the first column would have the name. Then I would like for you to rewrite these with domain and range. And then finally in the third column you would draw your picture. So that's how I want you to write these down. So I want you to pause the video and I want you to put these in your 3-column notes. Name in the first column, domain and range in the second, with the equation. I guess you could put the equation over here too. So this would be the first one, which would be f of x equals c, but you would also have constant function. Then I'd like for you to list the domain and range and then draw the picture. So I'm going to let you pause. I'm going to pause. You're going to pause and write this down, and I'll be right here waiting for you to go on to 1.7. These are the parent functions. One last thing. Remember that all the above functions can be found by creating a t-table, and then any other base function could also be found the same way, even ones that are not listed here. There is a special greatest integer function right here that we want to talk a little bit about as we go on. That's like this is a particular type of step function. It's also a piecewise function. It's parts of things. If the functions are given in transformation form, then you could sketch the graph from the base function using transformations. If not, then you just create a t-table and find more ordered pairs. This is just the basic information about parent functions. All right. I will move on to 1.7 after you get this written down. Okie dokie, go Bearcats. All right, we're on to 1.7, so please make note in your notes that we have changed from 1.6 to 1.7, title that. When I come around to look at your notes, I am going to look for that 3 columns on the parent function that you just did, so I'll make sure I'll be looking for that. The next thing I want us to talk about a little bit are transformations. This is something that's pretty comfortable, you're pretty comfortable with, so I'm going to just kind of walk through this pretty quickly till we get to the end, and then I've got an extra special example of one that you have not done a lot of, so we're going to have a little practice together. These are all vertical and horizontal shifts, so these are the shifts that would move up or down or left and right. up and down and left and right. What I would make sure and do, make sure that if you have a combination of transformations, in other words, you have more than just a horizontal or more than just vertical, and you have both of those transformations in a graph, please make sure you do your horizontal shifts first. So I'm going to just kind of make a little information here. You're going to make your horizontal shifts first if you have both vertical and horizontal. So notice that the horizontal shifts, you know that it's horizontal because it's in the parentheses with the x value. And remember, x is the horizontal axis, so you're going to be moving everything left or right if it has to do with the x. Notice up here, f of x would represent the function, and then outside that function would be your up or down movement. So that would be your y. That's not with the x value. That is going to be concerning your y values, which your y-axis is vertical, so be moving up and down. Also, don't forget anything with x sort of happens opposite of what you anticipate. So if it says x minus a value, you're really going to go to the right. If it says x plus a value, you're really going to the left. So the opposite of what you think. There's some really good examples on this page for you to look at, so take a look at these and sketch these in your notes. Okay, so you're going to draw each of these and match them up. So you're going to write vertical shift, upward, you're going to write vertical shift downward, horizontal shift right, horizontal shift left. That would be your first column of notes. In the middle, you're going to go ahead and write the formula that represents that shift. And then in the third column, you will match up your graph to see which one of these goes with it. So in actual, this first one is a shift upward, and you would match that up on your notes. I'll be looking for that, so take a little bit of time to do that, and then we'll move on. Okay, hopefully you paused and got your horizontal and vertical shifts done. Now let's take a look at reflections. There are two types of reflections, again, both which you are familiar with. In your column 1 of your notes, you're going to write reflection in the x-axis. In column 2, reflection in the y-axis. In that middle column, you'll go ahead and write the formula or the equation that represents those reflections. Then we're going to talk about them a little bit, and then you're going to draw the reflections that are listed here on the page. This would be, of course, a x-axis reflection, and this would be a y-axis reflection, and I'm going to let you figure out the last two, but I want all those examples with the appropriate reflection formula. Let's take a little bit about a look at this again. Remember, I said a while ago, anything that happens horizontally is with x, just like the x-axis is horizontal. So let's take a look at where we have negative x. Negative x is going to reflect things over the y-axis. It's going to reflect horizontally. It's going to go left to right. And if something moves left to right, okay, if it's moving left to right, then the axis that it's moving over would be the y-axis. So you would have a reflection in the y-axis. I think it looks like this down here, where you've moved from to the right side to the left side, from the right side to the left side. That's your y-axis reflection, and that is affecting your x values. That's why it's with x. So that's one that's a little easy to mix up. So make sure you're really, really clear. Notice this first one, you just have h of x equals a negative, and then the function f of x. Oh, I wrote a 1. I don't know why I wrote a 1. Negative f of x. Okay, that is not inside the parentheses with x, therefore it's going to affect your y values or your vertical movement, and so it's going to be reflecting up and down, up and down. And I may have said something incorrect a while ago. These are both moving up and down. This one's reflecting up and down. This one's reflecting up and down. Both of these would be vertical reflections or reflections over the x-axis. I think you know this pretty well, but make sure you have this written properly in your 3-column notes, and then we will move on. We don't have much longer to go. Okay, one of the last things we're going to discuss, and then we actually have a couple of examples to work, are non-rigid transformations. Non-rigid transformations simply mean that you have a distortion or a change in the shape of the graph. We have two major types of non-rigid transformations. We have where we stretch a graph or we compress. We stretch or we compress a graph. Okay, again, notice that we have this non-rigid transformation. It looks like multiplication at c times f of x. So we have one here and we have one here. And it does look like we're multiplying things, and we are sort of multiplying things. Notice that this one at the top is not with the x value, so this is going to be vertical stretch or compression, and the one at the bottom is with the x value, so it'll be horizontal stretch or compression. Just like before, anything that happens with x is opposite of what you think. So if it's with the x and it's 1/3, you'll be stretching by 3. If it were 3, you would be shrinking or compressing by 1/3. So it's kind of the opposite of what it looks like. Up here at the top, this is not with the x, so this is vertical, and it just does what it says. So if it's 1/3, you would actually compress by 1/3. If it was 3, you would actually stretch by 3. So if it's vertical, it's going to happen just like it's supposed to and just like it looks like in the equation. If it's horizontal, it's going to be sort of the opposite of what you would anticipate it being. Let's take a look at a couple of examples. I'm going to work one of these examples with you, and then I would like for you to work the other example. Actually, I'm going to work part of each example. I'm going to work, I guess I'll work this example, and maybe I'll work this example. And then I want you to do the opposites. First of all, the very first thing you have to do is just like in 1.6 that we talked about earlier, is you have to identify what the parent function or what the base function looks like. In this case, you're going to go over here and you're going to write the base function, which would just simply be y equals the absolute value of x. And personally, I really like to have my base points on my graph. I know not everybody does, but I do. So I'm going to come over here and I'm going to put my base points there. This is simply a V-shaped graph, and I know that. If you don't know that, you can create yourself a t-table to find your points, but just think about it. The absolute value of 0 is 0, the absolute value of 1 is 1, 2 is 2. The absolute value of -1 would be 1. The absolute value of -2 would be 2. So it's just this V-shaped graph. Now I'm going to look at the transformation. This is a outside of x, so I know this is going to happen vertical. Okay, vertical means with the y-axis, and it also means that it happens as it looks like. So this is going to be 1/3. I'm going to take 1/3 of my y values, or I'm going to compress my graph by 1/3. That's a little hard to do on this little bitty graph, but I think we can try it. So you can't so we're kind of squishing it up and down. We're squishing it downward toward the x-axis in this particular case. So I'm going to take 0. You really can't do that. So 0 compressed by 1/3 or multiplied by 1/3 is still going to be 0. Now let's go all the way to 3, because that'll be an easy one. If you take 3, the value of y is 3, and you compress it by 1/3, that's 1/3 of 3 would be 1. It's going to end up being right here. And the same thing symmetrically will happen on this side. Let's go here. 1, if you compress 1 by 1/3, you're going to be at 1/3. It's going to be right down here. And then if you compress 2 by 1/3, it's going to be at 2/3, which is 1 and a, which is not 2/3. 2 would be 2/3. 2/3 would just be about right, about right there. And we've got the same on this side symmetrically, and your graph would look like this. So it looks like it just squished the graph downward, which makes this graph wider. That's why it's non-rigid. It's not the exact form of the original graph. All right, let's take a look at the second example down here. And again, you're going to work this example. Ooh, I don't know why I have that on there. You're going to work this example, and you're going to work this example in a minute. But let's do the second one together. All right, this is the change is happening with x. So this is going to be horizontal. All right, so if it's horizontal, that means it's going to happen left and right, but it also means that it's going to be opposite of what we think. So this says 2 times x, which would indicate a stretch, but remember, since it's horizontal, we're going to do opposite, so we're actually going to go half the x values, or we're going to compress by 1/2. So our parent function. Our parent function here is y equals x squared. All right, first let's go ahead and put those points on there. And that's the first thing. If you don't get that right, then it won't matter what you know about transformations. So this is y equals x squared, parent graph of a quadratic, so at 0. 1 squared would be 1. 2 squared, though, would be at 4. And over here, -1 squared would be 1, and -2 squared would be 4. And there's your parent graph of your quadratic. So let's move those points around. You also should know those are a U-shaped graph. You really have to be familiar with that. So we're going to double half our x value. So we're going to compress it toward the y-axis by half. All right, so again, 0 compressed by half, you can't really do anything. Remember, this is opposite of what we think. Our 1, if we compress it toward the axis by 1/2, it's going to move it about right here. And at 2, we compress it by half, it's going to be at 1. And we can do these symmetrically. And our quadratic then is going to look a lot narrower than the original by half. And so again, it distorted the original shape of the graph. It just didn't move that shape around. It actually changed its shape some. That's a non-rigid transformation. All right, pause. Make sure you take care of these other two examples and in your notes very carefully, and then we'll move on to our last example. Okay, our last example for today, and this is a really good example because this kind of walks through a lot of different transformations and one that you're not as familiar with from last year. So this would be more of a pre-cal type problem. You're very familiar with most of the transformations, but we've not done a whole lot of practice with the combination of horizontal changes. A lot of things happening with the x values. So let's take a look at this and let's think of our plan. We have a plan here. The plan. All right, the plan first is I don't like what's underneath here in the way it's written. I always like my x values first. So that's the first thing I'm going to do. I'm going to rewrite this. So I know I have 2. And then I have the square root of, and I'm going to move my negative x to the front, and that 1 is positive 1, and I still have minus 2. Now, the other thing I need to do is I need to factor out this negative so it becomes its own transformation. So I'm going to rewrite again as 2, and you will be able to do this in one step after you've seen it. And you have a negative on the outside, and it would be x, and it would actually be minus 1. If you don't do that, you're going to get your transformation wrong. The first time you do these, it's kind of fun to go over just to check or verify on a calculator if you did the right thing. Or you can always verify if it's a problem in the book, in the back of your book, or your solutions manual. All right, so we've got that. So the next thing we want to do is we want to write our directions. We always want to write our directions for our transformations. Okay, remember I told you earlier the first thing you're going to do is all the horizontal information. So you're going to do everything that concerns the x stuff. So we're doing the horizontal stuff first. The other thing you're going to do is you want to make sure that you're reading it carefully. So the first thing we're going to do is we're going to go, we're going to reflect, use this, the negative as a reflection. And remember, that's horizontally, so it's going to reflect over the y-axis, something we're not as familiar with. Let me fill all that out. Okay, reflect over the y-axis. The second set of instructions is we're going to notice the inside here, we're going to move to the right 1. Then we're going to go back to the front of the problem, and everything else that's left is vertical. So these were horizontal, and the rest of this is vertical. And it's kind of important that you note that, because if you don't note that, then sometimes you just do it opposite of what you should. So it's just a check on yourself. All right, so the third thing we'll do is look in the front. That too is a multiply. It's multiplying, so it's going to be a stretch or compression. Since it's vertical, it will do what it says. It's going to double or stretch by 2. So I'm going to write double my y values. And number 4 at the end is minus 2, so it's going to shift down 2. Down 2. All right, well, the first thing I do is like I did before. My parent graph, or my base graph, is really y equals the square root of x. That would be before any transformation. So I'm going to go ahead and put those on points on my graph. If you need a t-table, create a t-table. Remember, 0, you can't have a negative under a square root, so the square root of 0 is 0. The square root of 1 is 1. Now, I'm going to pick wisely. I'm not going to pick the square root of 2. That's some decimal. I don't have a calculator. So I'm going to pick the square root of 4, which would be 2. That's probably enough for us on this problem. So let's plot those base points. We have 0, 0, 1, 1, and 4. 1, 2, 3, 4, 1, 2. Oh, if we wanted to pick another point, we would pick 9, 3. Let's see if we can get that on there. So 4, 5, 6, 7, 8, 9, 1, 2, 3. Yeah, we can. All right, those are base points. So let's now look at our map of what we're going to do. These are our directions to follow. So we're going to take these points, reflect over the y-axis. Well, you can't reflect 0, but you could move it right 1. And then you double the y values. Well, 0, doubling 0 is still 0, but you could move it down 2. 1, 2. So notice that your horizontal and your vertical shifts will always move your vertex or your 0, 0 point to the right place. The 0, 0 point can't be stretched or compressed or reflected. So it'll just be your horizontal and vertical shifts. All right, let's take the next point. All right, we're going to reflect over the y-axis, so it'll be over here. We're going to move right 1, which puts us here. We're going to double our y value, so we're going to move up to 2, from 1 to 2, we doubled it, and then we're going to move down 1, 2, and that puts us back at the origin. All right, let's take another point. So we're at 4, we reflect over the y-axis, putting us at negative 1, 2, 3, 4. We're going to move right 1, that puts us at negative 3 on the x-axis. Double the y values. Well, y is 2, so we're going to make y 4, and then we're going to move down 2, puts us back at y 2, and there's another point. Let's go ahead and see if we can do this third point. We would reflect over the y-axis, that brings us all the way over here. We would move right 1, moving us back to 8, it looks like. Double the y values. We're at 3, so that makes us go all the way to 6. 1, 2, 3 more. And then down 1, 2, and that would put our point right here. And our graph then would look like this. And you can check that out on your calculator. Be very careful when you put it in there. All right, that's all I have. Make sure you pause and have written this example down because it's a really good example for pre-cal. Hint, hint. And I will see you Tuesday. Have a great evening, Bearcats.